All right. Now, for this one, this game is a good one for you to try with a friend, a family member, a parent, whatever it happens to be. So, when we're taking a look at this game, we call it the game of NIM. And the way it works is traditionally you do it with coins, but you could do it with anything, blocks, pens, doesn't really matter. And you're going to set out a certain number of them. There's always 2 players, and each player at any point gets to grab either 1 or 2 of whatever the object is. Like I said, traditionally a coin. So the goal is you always want to be the person to take the last coin. So if Nguyen and Henry played the simplest variation to see if a winning strategy can be discovered, they set up 1 pile of pennies, and each player must remove 1 or 2 pennies from the pile in alternating turns. Nguyen will be player 1, and Henry will be player 2. They begin with 1 penny in the pile and start the game over, adding another penny each game until they reach 6 pennies. So, when they play with 1 penny, well, whoever is the first player can just take that penny. They can always win. When they play with 2 pennies, then, because the first player can take 2 pennies, then they always win. The pattern changes once they get to 3 pennies, because if the first person takes 1 penny, then the second player can take the 2 remaining ones. Or if the first person takes 2 pennies, then the other player can take the only remaining one, which means that player 2 will always win. Now, if you did this correctly, you should find that when you get to 4 pennies, player 1 can always win. Player 1 will just take 1 penny. Player 2 will be left with 3 pennies, and they'll be like if they were player 1 with 3 pennies, player 1 can always win. Player 1 takes 1 penny, player 2 can either take 2 or 1 pennies, and then player 1 will take whatever's remaining. At 5, player 1 will always win again. He can take 2 pennies to start, and then you're in the same situation. Once we're at 6, player 2 can always win. So, if you play the game with 4 coins, can you come up with a strategy for player 1 to win every time? Just start by taking 1 coin. Then it doesn't matter what player 2 takes, you can always take the rest of them. Alright, so if we're completing the list for the players' winning statements, if it starts with player 1, take 1, start with 2 pennies, player 1 takes 2 pennies, start with 3, player wins because no matter what they take, whatever player 1 takes, they'll take the rest. With 4 pennies, player 1 takes 1 penny and leaves player 2 with 3 pennies to take. Once we get to 5 pennies, player 1 takes 2 pennies. Leaving player 2 with 3. Whatever player 2 takes, then player 1 takes the rest. If I'm starting with 6, player 1 takes 1 or 2 pennies. And player 2 takes enough pennies to leave player 1 with 3. And then they're going to be in the exact situation if they had started with just 3. Okay. So, if we say it's Ewan's turn, what is the smallest number of coins that can be left by Henry so that Henry knows he will always win? Well, the example is 3. If you leave it with 3 pennies, you're always going to win. It's Ewan's turn. What is the second smallest number of coins that can be left by Henry so that he knows he'll always win? Well, we know that if he's at 6 pennies, the same thing holds true. Ewan and Henry realized that a winning strategy may involve a link between the number of pennies in the pile and the number of pennies that the first person removes. So, if we play the game several times with 7 pennies and devise a strategy that player always wins, player 1 should take 1 penny leaving player 2 with 6. And then once we're at 6 pennies, the same pattern follows. Always take away pennies relative to the other player so that you're always leaving them with a multiple of 3. So the pattern will continue. With 1 pennies, player 1 takes 1, and player 1 will win. 2 pennies, they take 2, player 1 wins. 3 pennies, doesn't matter how many they take, player 2 can always win. And then the pattern continues. At 4, it's going to be 1. At 5, it's going to be 2. At 6, it's going to be 1 or 2, because player 2 will always win. At 7, it's going to be 1. At 8, it's going to be 2. And at 9, it's going to be 1 or 2, because player 2 will always win. At 10, take 1. At 11, take 2. And then the pattern will just go on, literally forever. So, which player, the second or the first, has control of the outcome of the game if the original number of coins in the pile is 12, 25, 50, or 300? Well, literally any time it is a multiple of 3, player 2 is going to win. Any case where it's not a multiple of 3, player 1 can always win. Which means that for 12, it's going to be player 2. Because that is a multiple of 3. At 25, it's going to be player 1. At 50, it's going to be player 1. And at 300, it's going to be player 2 again. Because once again is at a multiple of 3. All right, last example for this. Brienne asked Joanne to choose any 4 days, numbers in the month of September that form a square. An example is shown where she highlighted these 4 days. Brienne told Joanne to tell her only the sum of the 4 numbers. Brienne said that she could correctly tell Joanne the calendar days she had chosen. So Joanne said the 4 numbers add up to 72, and Brienne correctly guessed the calendar days as the 14th, 15th, 21st, and 22nd. Brienne used deductive reasoning to determine the numbers. Part of her reasoning is shown below. Let's complete the work. So if the smallest number is going to be n, then the other 3 numbers are going to be 1 more than the smallest number. So we call that n plus 1. The 12, in this case, would be a week later, so that's going to be n plus 7. And the 13 would be a week and a day later, so we'll call that n plus 8. Now, in this case, if we said that n plus 1 plus n plus 7 plus n plus 8 have a sum of 72, then when I combine all the n's on the left-hand side, I actually have 4 n's, and when I take the 1 plus 7 plus 8, it's going to add up to 16 is equal to 72. Then I would subtract the 16 from both sides and say that 4n is equal to 56, and divide both sides by 4, n is equal to 14, which means that the first number is 14, the second number is going to be 14 plus 1, or 15, then 14 plus 7, 21, and 14 plus 8 is equal to 22. Because we know that it's always going to add up to 4n plus 16, taking any 4 days, then I could always use this pattern. If I know what the sum of the days are, any sum, I'm always going to take the sum, subtract 16, and then divide by 4. It will always tell me my starting number. Okay, try some practice with this.